All right, welcome. If you're getting stuck into your AQA GCSE Physics revision, then you are in exactly the right place. In this explainer, we are going to break down everything you need to know about the particle model and pressure from section 4.3.3. Come on, let's get you exam ready. So let's kick things off with a simple question. We've all used a bicycle pump, we've all blown up a birthday balloon, but what's the actual physics that connects the two? Well, the answer, believe it or not, is all about how gases behave under pressure. It's about how these tiny, totally invisible particles can create enough force to actually inflate something. Okay, let's dive into this. First up, we need to get our heads around the absolute basics, the fundamental model that this entire topic is built on, how we as physicists actually think about gases. This right here, this is the core idea that everything else builds on. The particle model tells us to picture any gas, not as just empty space, but as this chaotic dance of countless tiny particles, all zipping around completely at random. So, what exactly are these little particles up to? Well, they are constantly moving, completely randomly, bumping into each other, and, crucially, the walls of whatever container they're in. Now, the hotter the gas gets, the more kinetic energy these particles have, which just means they move faster. And every single time a particle smacks into the container wall, it gives it a tiny little push. Billions and billions of these tiny pushes every second add up to create what we feel as pressure. It's kind of like a million tiny tennis balls all bouncing around inside a box. Okay, so let's link those two ideas together. Imagine you've got a sealed container of gas, so the volume can't change, and you start to heat it up. What happens? Well, the particles get more kinetic energy, they start moving a lot faster, and that means they hit the walls harder and more often. The result? The pressure inside that container goes way up. Being able to explain that simple relationship is an absolutely key skill for your exam. Now let's see how this builds into the next key area. And just a quick heads up here, what we're about to cover now is specifically for those of you taking the separate Physics GCSE. If you're doing combined science, you can just sit back and relax for this bit. Remember all those collisions we were just talking about? They're not just happening in one direction. Oh no, they're happening all over the inner surface of the container, creating this constant outward push, a net force that always acts at a right angle or perpendicular to the walls. Now let's do a little thought experiment. Picture a gas trapped inside a syringe. If we make sure the temperature doesn't change, what do you think happens to the pressure inside when you push that plunger in and squeeze the gas into a much smaller space? And the answer beautifully illustrates a key relationship in physics. If you decrease the volume, those exact same gas particles are now crammed into a tiny space. They're going to hit the walls way more often, causing the pressure to shoot up. And the opposite is true too. If you increase the volume, you give them more room to roam, they hit the walls less frequently, and the pressure goes down. It's what we call an inverse relationship. And in physics, wherever you find a clear relationship like that, there's usually an equation to go with it. For a fixed amount of gas that's kept at the same temperature, the pressure multiplied by the volume will always equal a constant value. The fantastic news is that this equation, PV equals constant, is actually given to you on your equation sheet. Your job is just knowing when and how to use it. Okay, it's time for our final concept, and this one brings us full circle, right back to that bicycle pump example from the very start. Now, one more heads up. This bit is specifically for you higher tier physics students. If you're doing foundation tier, you do not need to worry about this next part. So, for all our higher tier students, let's really focus here. This is a key application of these ideas, and it's a topic that examiners absolutely love to ask questions about. So, think about it. When you push down on a bicycle pump, you're applying a force, and you're moving the handle over a distance. In physics, that has a special name. You are doing work. And in this specific case, you're doing work on the gas that's trapped inside the pump, compressing it into a smaller and smaller volume. And this is so cool because it explains something you've probably actually felt in real life. Have you ever noticed that a pump gets warm or even hot when you're using it? Well, here's exactly why. The work you do by pushing that handle transfers energy directly to the gas particles. This increases their internal energy, which is just the total kinetic and potential energy of all the particles put together. And that increase in internal energy is what makes the temperature of the gas rise. So the absolutely crucial point, the main takeaway for this higher tier topic is this. Compressing a gas isn't just about changing its pressure and volume.
When you do work on it, you're actively pumping energy into the system, and that can cause the gas to get hotter.
And that's a wrap on this key section. We've seen how pressure, volume, and temperature are all beautifully linked together. But it leaves us with a question, doesn't it? What happens if you change all three at the same time? Well, that's a question for the next stage of your physics adventure. Best of luck with all your revision.